All right, and we are off to number 9. Hopefully, trying to move through these a little bit faster. But number 9, we are just going to be solving this equation. So 0.8 minus 4x is greater than or equal to 4.8. We're just looking for x, so we are going to subtract 0.8 on both sides so that the x is by itself. We have negative 4x, which is greater than or equal to 4. Now remember, if we're going to multiply or divide by a negative number in an inequality, we're also going to flip the sign so that we have now x is less than or equal to 4 divided by 4, which is by negative 4, which is negative 1. So if it's greater than or equal to, we're looking for a closed circle. And if it's greater than less than or greater than, we're looking for an open circle. I'm going to be looking for a closed circle here. That's gone. And then it needs to be less than negative 1. Less than goes to the left, while greater goes to the right. So because x is less than, we're going to the left. That is our answer. Number 10, nice and easy. They just want me to graph one thing. I need to find my slope. The slope is the number in front of the x, which is negative 1. I don't see a 1 there, but it's implied. And then your y-intercept is positive 3. So this is where we start at the positive 3. My slope, negative 1, I need a denominator. Negative 1 over 1 means I'm going to go down 1 and then right 1. So down and right, down and right, down and right, down and right, or up and left, up and left, up and left. Number 11, they want you to select all the statements that are true about this. The relation shown in, this is not a mapping diagram. In fact, it is just a regular table. You have your x and your y's. Remember, your x refers to your domain, or your domain refers to your x, and your range is your y. We know if it's a function if the domain does not repeat. So this 1, 2, 3, 4, 5, none of those repeats. The relation is a function because the domain did not repeat. Domain does not repeat. The domain is 1, 2, 3, 4, 5. Yep. The range is, no, that's not the range. The domain is, nope. And the range is that. Yep. There we go. We're all good to go. Number 12, we're just going to read and create a graph for it like we have done with the T and the temperature. There's an eagle. All right. Takes off from a cliff. Cliffs are usually in the air. So this is where the eagle is taken off from. Bird, that's the eagle, the cliff. When they take off, initially they drop. Then she remained at that same height. Then she descends until she reached the ground. So this is a decrease, and then it's constant, and then it's a decrease again because it went down. So let's see, decrease, constant, and then decrease. Boom. Number 13 says the rule for a function of x is multiply the input value by 2. So whatever x is, I'm going to multiply it by 2 and then subtract 6. So my y, the output, is equal to 2x minus 6. They gave me the input, meaning they gave me the x values. So when x is negative 1, 1, 3, 5, etc. So now let's do it. Let's do another color here. When x is equal to 1, negative 1, we're going to do y equals 2 times negative 1 minus 6. So that y is equal to negative 2 minus 6. Y is negative 8. Is that an answer choice here? No. So now I need to go to the next one. Let's do green. That's when x is equal to 1. So when x is equal to 1, then y is equal to 2 times 1 minus 6. And this is just a game of substitution, right? 2 minus 6, y is equal to negative 4. Is negative 4 an option here? Nope. I'm going to keep going. purple. When x is 3. So when x equals 3, y is equal to 2 times 3 minus 6. Y is equal to 6 minus 6, which is 0. Not an answer choice. All right, I think that's the last one that's going to work. But let's figure out when x is equal to 5. When x is equal to 5, then y is equal to 2 times 5 minus 6. Y is equal to 10 minus 6. Y is 4 then. That is it. That's an answer. So, of all of those, that output is what would work. All right, now we're going to come down. Which scatter plot best represents a linear function? Remember, linear function, L-I-N-E-R, linear function makes a line. So you're looking for a line. Is that a line? Nope. Is that a line? Nope. That's a curve. Is this? It's not even a line. Is this a line? It's a little wonky, but it is the best one that looks like a line. So we're going to go here with D. Coming on down to number 15. They want us to use the table of values in parts A, or to answer part A and B. So I'm using this table. And part A simply says to graph the ordered pairs on a coordinate plane and draw the line through them. We could do that with our eye closed. So this is 2, 5, 4, 10, 8, 20, 14, 35, and 18, 45. And just to recall, so we know, each of these coordinate, or each of these is a coordinate. So that's 2, 5. This is saying that it's 4, 10. It's an X and a Y. So then it's 8, 20, etc. That's where we're getting those points from. So then there you go. And then here's the line that will go through it. Part B says, does this represent a proportional relationship? And the answer is yes, it does. It is proportional because the graph is a straight line that passes through 0, 0, the origin. If it goes through 0, 0, it's proportional. If I had a graph, let's see, this is my X and this is my Y, and the line was this red one going through, that is not proportional because it does not go through 0, 0. So that's non-proportional. If you have the graph and the line goes directly through 0, 0, this is proportional. All right. So coming on down, I told you these would be a little faster. Which graph represents y as a function of x? Which of these is a function? Boom. See how it hits twice? Remember, if it hits twice on the graph, it is not a function. Oops, not a function. This is special, but you see how it just goes straight up all the time? Not a function. Not really. See how we have our line, and every time I go, it only hits once. Each domain is once. This is a function. The domain is used only once, whereas here the domain is used for every single coordinate point. All right, number 17, you haven't heard of. You can, just try your best, meh. But the square root of 50, they want to know if it's rational or irrational. Rational people make sense, right? So if a number is rational, it simply means that it is a repeating decimal. You could tell what's happening. Like 1.3333. That's rational. We know what's going to come next. Maybe you have a decimal that stops. So 2.4. That is also rational. It ends. So this is rational as well. Even a whole number. right? That's rational. It's just a number. Irrational is a number that does not terminate, it does not stop, and you don't know what's coming next. So 2.137694296637. It's continuing. See that dot dot dot. And there is no pattern. You don't know what's coming next. This is irrational. There's no pattern to it. People who are irrational, you can't speak to because you don't know what they're going to say next, what they're going to do next. They're unpredictable, right? We say that they're irrational. There's no pattern to them. Ooh, one second. I'm a little bit sick. The ones, because when you found the square root of 50, you'll see it in the calculator. It just keeps going. Doesn't give you any kind of pattern. It's going to be irrational. And that's just you putting it into the calculator. Do the square root of 50. All right. Number 18, what is the solution for x in the equation? X to the third. That means a number times a number times another number is going to give us 125. In the calculator, you can put in the cubed root. You may not know. This is also fine. But the number is going to be 5. 5 times 5 times 5 is 125. All right, so x is equal to 5 here. Now, they want you to tell all the functions that are linear, meaning all the ones that make a line, linear line. So number 1, I'm not sure. Let me get a little graphy thing and just kind of sketch it out, and let's see. 5, 10, 15, all the way to 60. So let's do 10, 20, 20, 40, and 60 here. All right, so that means that's 10. 5 got to be here. And then my numbers here, I'm going to make them by 50s. 50, 100, 150, 200, 250, and 300. All right, so I have 5 and 300. There you go. I have 10 and 150. Oh, that's way down there. I have 15 and 100. And then I have 20, 30, and 50. And then I have 60 and 25. Oh, this is definitely not a line. Okay. This one, y equals mx plus b. That's what we've been using to graph. That's a line. This curvy thing, not a line. This straight one here, yes, it's a line. You see this one? It's actually also a line because your highest degree is 1. Now, it doesn't look like mx plus b, but it is. You could always just move the x over, and that would also be a line. I'm not holding this one against you. On this last one here, you could try it. Oh, I don't need all that. I can go here, sloop. Okay. Oh, 1, 2, 3, 4. And then this is, let's go by 0.5s. 0.5, 1, 1.6, or 1.5. I gotta do that. All right, so then I would come here and I'm at 1 and 0.1. It's gotta be here-ish somewhere. I'm at 2 and 0.4, which is under the 5. Okay. I'm at 3 and 0.9, which is here. And then I'm at 4 and 1.6, which is up there. And I can see that's not really a line. That kind of gives me a curve. Oh, because it goes through 0, 0, 2. This is not linear. So then my linear functions would be 1, 2, and 3. I'm going to go ahead and find out what two numbers those happen to be between. We know how to put that in the calculator. Negative 4.3 plus the square root of 11. Just type it in. And when you find that, you're going to get, let's see, what's that when I put it in the calculator? This is going to give us negative 0.983. Well, that's going to be between negative 1 and 0 because it's less than 1. Well, it's less than 0 and it's greater than negative 1. So it's going to be between negative 1 and 0 on a number line. All right, so now we're going to do something similar to what we just did. We're just going to pick the ones that are non-linear. So which ones are not a line? That's a line. I can't pick it. All right. When I look at the second one, I could get myself a graph. Oh, nope. I also wanted to go the other way because I see that I have negative numbers. So now I'm looking at 1, 2, 3, 4. And then I'm looking at, oh Lord, 4, negative 8, negative 12. And then 4 and 8. All right, so now I'm looking at 0, negative 12. That's down here. Get a different color. Then I'm looking at 1, negative 7. Should be somewhere here. I'm looking at 2, negative 2. Somewhere here. I'm looking at 3, 3. Somewhere there. I'm looking at, what's that next one? 4, 8. Somewhere there. So then I see that kind of getting me a line vibes. So that is also a line. That's not it. So this is a line. Yeah, this looks like a line. Oh, this is not a line. It's not y equals mx plus b. It actually also has a 3 on it. And we don't have a 3 on our linear functions. So that's not linear. Okay. This is not linear. That's going to be linear. If you want to make a graph, goes through 0, 0, positive 1, 2, 3, 4, go by 12, 12, 12, then 24, then 36, then what's that, 48. So 0, 0, 1, 12, 2, 24, 3, 36, and 4. The other thing, yep, that makes a line-ish. So it is linear, can't be nonlinear. This is a V, clearly not linear because it's a V. So that's nonlinear. And then we know that last one is. All right, so let's go. 22, what value of x makes the equation true below? We're going to have to solve. Told you solving equations would be here. So let's solve this equation. We have 24x plus 33. And that's equal to 3 times 5x plus 21 and minus 9. We're going to simplify the left. We're all good over here. So now I got to simplify the right. I'm going to distribute. I get 15x, 3 times 21, that's 30. No, sorry, 3 times 21, that's 63, plus 63 minus 9. Then I'm going to simplify the right some more so that we have 24x plus 33 is equal to 15x. 63 minus 9, that's 54. Then I'm going to get these x's together. So I'm going to minus 15x on both sides. So I have now 9x plus 33. That's equal to 54. Then I'm going to get that 33 on the other side, inverse operation. I have to subtract 33. So that 9x is equal to 54 minus 33, which is going to give me 21. Then I divide both sides by 9, and x is equal to 21 over 9. But then I need to simplify this. So x is equal to, I could divide them both by 3. Yep. So that x is equal to 7 over 3. Remember, here in algebra, we're going to leave it improper. And that's what we will type in. So 7/3. All right, coming on down. I think we're almost done. Number 23, we're also going to put that in the calculator. 2 plus square root of 10. When I put that in the calculator, I'm going to get 5.16. Once I know it's 5.16, I'm going to look at my number line. This is 5. This must be 5.1 then, because that's 5.2. And so B is between 5.1 and 5.2. And your answer is B. 24 says which function, or function A and function B are shown. So those are 2. Which function has a greater rate of change? Rate of change is the same as slope. So we're looking for the slope for the answer, and then I got to find which one is bigger. Now, if I'm looking for slope from a table, I pick 2 points. Doesn't matter which 2 point, you pick 2 points and you use the formula, right? So your slope is equal to y2 minus y1 divided by x2 minus x1. And you could write them if you want. And 4, 24. This is my x1, y1, and x2, y2. So my slope is equal to 24 minus 12 divided by 4 minus 2, which is going to give us 12 over 2. So the slope is 6. The slope of the table is 6. So now, to compare it, we need to find the slope of the graph. I could pick 2 points, but I could also go rise over run. So I could count up 1. That's a perfect point. That's a perfect point. I could count up 1 and write 2. So my slope is 1/2. Well then, which is greater? The slope of function A is greater. Oh, Lord. All right, we have 2 to go. Here's the graph of a line that is shown. We want to know what is the equation of this line. Again, we're going back to our bestie, slope-intercept form, y equals mx plus b. Your y-intercept is here at 1, so b is equal to 1. And now let's look for the slope. Perfect intersection here, perfect there. All right, so then I could go up 1, right 2, up 1, right 2, up 1, right 2. My slope is 1/2. So my equation should be 1/2 x plus 1. And here it is at A. All right, lastly, what an equation below is shown. What is the value of x? Oh, we're solving a 2-step equation to finish this out. Yay! We're going to add 8 on both sides. So that negative 5x is equal to 28. Then I'm going to divide both sides by negative 5. So that x is equal to, what's that? Yeah, that's it. Negative 28 over 5. Can I simplify it? I don't think there's any number that can go into both 28 and 5. So here in algebra, again, we're going to leave these things an improper fraction. There we go. It is negative 28 over 5. This is it. Thank you so much. If you have any questions, go ahead and pause and rewind. Ask me something quick before the final, and I'll see you then. Bye-bye.